You've probably encountered a lot of these tables when searching for the trigonometric identities before math exam, and you found yourself lost in all those formulas. But don't worry, because trigonometry can be easy. And today, we're going to talk specifically about the double angle identities and derive each of these formulas. Before talking about the double angle identities, we need to remember how to calculate the sums of angles for the sine, the tangent, and the cosine. I'm showing you the formulas right now, but don't worry if you don't remember those formulas, okay? Because I'm going to review them later. Let's start by the sine of a double angle, okay? And you see that's pretty easy. We just need to start from here, okay, by the sum of angles. So we have that the sine of a plus b equals sine of a cosine of b plus cosine of a sine of b. And now we just let a equals b. So we have that the sine of a plus a equals sine of a cosine of a plus cosine of a sine of a. And from here we get to our double angle formula for the sine, because a plus a is double the angle, is 2a. And here we're adding two things that are the same. So we have that the sine of 2a equals 2 sine of a cosine of a. All right? Now we can go to the cosine. Okay? It's pretty similar to the sine, right? So you just need the formula of the sum of the angles. So cosine of a plus b equals cosine of a cosine of b minus sine of a sine of b. And again, we let a equals b. So we have cosine of a plus a equals cosine of a cosine of a minus sine of a times sine of a. And from here, we get to our formula, which is cosine of 2a, double the angle, equals cosine of a squared minus sine of a squared. And now for the tangent of a double angle. And you see that's pretty easy too, because we just need our sum of angles formula. So the tangent of a plus b equals tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. And here you know what we need to do, right? We just let a equals b. So we have tangent of a plus a, that will be 2a, double the angle, equals tangent of a plus tangent of a over 1 minus tangent of a times tangent of a. And from here, we get our double angle for the tangent, which is 2 tangent of 2a equals 2 tangent of a over 1 minus tangent squared of a. Now, we've talked about the sine, cosine, and tangent double angle formulas, but let's go back to the cosine, because there's some other ways to derive the double angle formulas for the cosine, and that's by using the Pythagorean identity, the most famous trigonometric identity we have, right? Which states that the sine squared of an angle plus the cosine squared of the same angle equals 1. Now, we can isolate the cosine squared, all right, and use the identity we've just derived previously for the cosine, okay? Because we have a cosine squared here and a cosine squared here, now I can substitute this into the other formula. And when we do it, we derive another formula for the double angle of a cosine, okay, which is 1 minus 2 sine squared of a. And we can do the same, but now isolating the sine squared and substituting into the cosine double angle formula. And now we have another cosine double angle, which is 2 cosine squared of a minus 1. So here are some of the double angle formulas for the cosine, sine, and tangent. And stay tuned because we're going to solve some problems in the next videos, okay? So that's it, hope you enjoyed and see you next time.
Don't forget to check out our other math videos and subscribe for more.